Welcome to this video, and I'm Stephen Borsay, and I'm going to talk about the new Amazon Timestream. This is kind of a database, but actually it's kind of more of a data ledger system, and I'll compare and contrast it to DynamoDB, but the good thing about this database, as I'm going to talk about in these next few slides, it's extremely good for IoT data. Data that we don't need to persist, we don't need a high level of security for, and we just want to do some quick and easy analysis for. So I'll talk about that in a second, but basically if you look at this diagram, we can look at the left side as our IoT data coming in with a direct rule and action to Amazon Timestream, and then once it's held in that data ledger of Timestream, we can analyze it with visualization tool. I'm going to show you how to do that real easily in Grafana. But you can also use SageMaker to do models in PyTorch or Python or Spark or different kind of analytical packages. So I look at Timestream as a quick and easy database, especially well suited for IoT. So what may be the difference between Timestream and Dynamo? Well, first of all, in my experience playing with this for a couple weeks, this Timestream's a lot cheaper. That's the good news. Timestream's also much easier to set up. We can set it up directly from AWS IoT Core without too many problems. It also has built-in Athena-like SQL queries. So if you've taken my course before, sometimes we're sitting with a data lake in S3 or data in DynamoDB. And then we have to go through a procedure of analyzing that data and getting some kind of schema with AWS Glue and then running queries on it with Athena or even Redshift. We don't need to do that with Timestream. We can get Athena-like queries directly from Timestream, so that's really nice. And Timestream's really not appropriate for handling heterogeneous data either, nor is it really well integrated as much as Dynamo is, their number one database, with a lot of these different AWS services. So there is some official AWS videos that came out a couple weeks ago. In fact, this may be the video I'm making right now. It may be the only video that's not an AWS video on Timestream. So I'll link the three that are kind of relevant to this video, but I think this video has a space where AWS doesn't really cover some of the direct integration I want to make with AWS IoT Core here in a second. My video, I would say, is a little bit easier than what they're kind of go overing in the AWS videos. Those are kind of made more for their professional customers. This one's easy to get you started with Timestream integrated with AWS IoT Core. Also, a big benefit of the videos I'm going to make here, I'm going to make this first video with AWS IoT Core putting data into Timestream, and the next video I'll go over integrating with Grafana. But unlike the AWS videos, we don't have to set up the Grafana CLI, which is a locally installed command line interface. We're not going to use the AWS IoT SDK in JavaScript or Python to run a local producer using Python 3 and Bado. Now, these producers is simply just a program that produces random IoT data packages. We're going to do that directly from AWS IoT. So we're not going to have to run a local producer using Python 3. You can also, and I've seen this done before, you can run a producer program in Lambda, and you can also run in Cloud9. Another big benefit of my video is with Grafana in the next video, you're not going to have to make a credential file in a specific format, and you can find that and I'll link it in the AWS developer guide for Timestream. I'm simply going to plug in my SIG-v4 credentials directly into Grafana with a user that's just constructed for Timestream. And one thing to remember, people get confused about this SIG-v4 credentials. SIG-v4 is simply Amazon-specific user ID and secret key. So when you make a user, whether it's a limited privilege user or super user, you're given two keys. One is your user ID and one is your secret key. Finally, when we're in Grafana in the next video, I'm just simply going to use the cloud-based install. So no Grafana files to install locally on the computer, which I think is a big help. And with the little data package that I'm going to produce, we're simply going to do a graph without having to sideload a pre-made graph showing like 30 different variables. So it's going to be super easy. So let's move on now that I've done this introduction and talk about sending data from AWS IoT Core to our Grafana table, and I'll show you how to design and construct that all moving forward from this video. Okay, so now I'm going to show you how to complete the AWS IoT to Timestream integration, and the next video we'll do some visualizations. So you need to be in a region that supports Timestream. I'm in US West 2, Oregon. That's the region closest to me. But US East 1, North Virginia. Generally for my students on my Udemy course, I generally consider that the easiest region to get in because they get these new AWS services first. So make sure you have Amazon Timestream available. But I don't need to go to Amazon Timestream. I can actually construct my Timestream table directly from IoT Core. So go ahead and click IoT Core, and I'm simply going to create a new rule. So I'm going to go over here to Actions, Rules, and go ahead and create a new rule. And I'm going to name my rule Timestream DB 8. How about that? Pretty catchy name as always. And I want to construct this in a certain way because when you fill the database with Timestream data, it doesn't really work being columnar format the same way Dynamo or actually a lot of the RDS databases work. So I'm going to do something a little bit different because there's some what I consider some oddities to this. So rather than normally what I do and take the whole incoming IoT package, I'm simply going to extract a couple variables I want out of there. So the two I'm going to extract are temperature, you know, your typical IoT data payload test package, and humidity. Great. And I'll keep that as my rule. Again, I'm not going to take that wildcard star as a whole data package, and I'll just keep my topic as IoT/topic. That's fine for now. Okay, let's go ahead and add Timestream now. So go ahead and add this action. And the very last one, these tend to be in date of release, is let's write our message, which is our incoming data payload, to a Timestream table. Go ahead and click that and configure action. Now, unlike in the past, you used to have to go to a different service to construct your database or your additional service needs to integrate to AWS IoT Core. They've changed that. Now you can construct it directly from AWS IoT Core. So that's what we want to do. Let's create a new Timestream database. So I'm going to say create new database. So you have two options here. You can either take a sample database, and there's two pre-made sample databases that are already filled with information that you can use in data. And if you go again to those AWS official videos, they'll show you how to do that. We're going to create our own database for this. So I'm going to say standard database. And we can call this anything we want. Let's call this Timestream DB. I'll just say 8 as an extension. I'm going to keep the default encryption extension on here like this. And go ahead and create this database. It's going to take a second here, create our database. And you don't see it on here, and the reason is I'm on page 2. So I'm going to go to Timestream DB. That's the one I just created here. And I'm going to need to create a table within my database that I just created. So it really doesn't matter what I call my table as long as I remember what it is when I want to integrate it to AWS IoT Core. So I'll say my Timestream table. 8. Doesn't really matter. It's a good idea to pick a memory retention period. I'll pick, say, 2 days, and then it'll move over to magnetic storage if I'm not using it after 2 days, and I'll have 3 days of magnetic storage. I'm not going to use any tags, so go ahead and create that table, and that table will be held within our database. All right, great. So we have our database, and we have our table within our database. So now we can come back here to the previous tab that does it automatically, right back to AWS IoT Core, and now I'll refresh this, and now that database that I just created and hopefully you just created with that table will now be populated, and here it is right here. And then we only have one table in that database, and that's it right there. So that's all we have to do. That's about the easiest database creation you're ever going to do in AWS. Okay, so now we do have to do dimensions, and we're going to add our timestamp. So you remember in our IoT topic, I selected out of there humidity and temperature. So what's odd about Timestream DB, it's still actually going to send the whole package through, even though I only wanted to filter for those two variables. So given that, let's add a third variable that I'm going to hard code as a literal. So a typical one we like to use, and we'll name it device ID. We're going to name it here's device ID, but when I send the package in, I'm going to call it device ID literal here. So it has to be spelled like this when we construct our IoT payload. So again, it's going to be called device ID. We can call this whatever we want here when we construct our Timestream table with incoming data, but the literal name in our IoT Core JSON package needs to match this exactly as a literal. And I don't want a dash, I want an underscore. I'm just being picky about that. It's a time-based, time series database, just like InfluxDB or timescale. So we always want that time dimension. So here it is. This is going to be an automatic function that's going to timestamp our incoming JSON IoT payload when it comes into AWS IoT Core. Then the final thing we want to do is go ahead and create a role that'll give us access to Timestream DB. So I'm just going to go ahead and create a default role. And I'm just going to say Timestream role 8. And if we actually go to IAM and look what this role is, it's simply going to be a put into Timestream DB. So let's go ahead and add that action, and we're almost done here. Okay, so we have the selection here we want. We have our Timestream table here. We don't need to edit that. I'm not going to add an error action. I'm not going to add any tags, so go ahead and create that rule. And then finally, if you have any old rules enabled, like I do up here, I'm going to say disable this, and I want to make sure my Timestream rule I just created is enabled. Awesome. So we're good to go. So all we need to do now is start sending data package through AWS IoT Core to fill our Timestream data table. And again, the big difference in this video between the AWS official videos is I'm not going to use a locally installed or a Cloud9 or Lambda-based producer program. I'm just going to send like 5 or 6 simple data packages directly from IoT Core. So let's do that now. Go ahead to the test. And we're going to publish to that topic that's specified in the previous rule. So remember that was IoT topic /topic. That's what we need to put as our topic to make sure it gets intercepted by that rule. So let's go ahead and send in our data. Do you remember what those 3 variables were? Temperature, humidity, and device ID. So I'm just going to say the first one, temperature. And let's make up a fake temperature. Make sure I put it in JSON format. I'll say 66. It's fairly cold. That'll be in US Fahrenheit. Second one, humidity, our key value pair. And let's go humidity 77. And then finally, let's do the device ID. Now remember, the device ID, well, actually all 3 of them have to be spelled exactly right to be intercepted by our rule in AWS IoT Core. So to spell it exactly right, it's the underscore one, the literal device underscore ID. And this will also be a string for this dimension. So I'll just say sensor, this will be sensor 1. How about that? All right, that format should be correct. Everything looks to be spelled correct. Double check that you spelled everything correct. Let's go ahead and publish that. Okay, so what I want to do now is just change some of these readings here. So we get a graph we can have in Grafana that's going to look cool. So I'm going to create a linear reading. So I'm just going to keep pushing up the temperature and humidity and make them as different sensors. But you can really fill this out any way you want. So I'll make this one say 76 and the humidity 87, and I'll just call this sensor 2. And again, you can do this any way you want and make sure you're in the proper JSON format. Now, one thing to mention here is you want to make sure you keep this proper format and names, because if you misspell temperature or humidity, it's going to add a whole new column and kind of ruin your database unless you want to really fetch out different columnar data, which you don't want to do. You don't want to make your life hard. So I'm going to publish that. And I'll just say 86 on this. And how about 97? So it's just climbing in a linear manner. And we'll call this sensor 3, publish that. I'll do a couple more. How about 96? And then how about an unrealistic humidity reading of 107? I think hundreds actually as a percentage is the highest humidity you can have, but we'll do that. 4, publish that. And let's do one more reading of 100 and... I don't know, 117. How about that? We'll just have to change this over here to 1. I think that's enough readings here. And it's going to produce reading each for humidity and temperature, because that's the way it works. I'm going to show you that next. So we'll call that sensor 5, publish this. Now let's go check out what our database in Timestream and our table looks like. So go ahead and come over here. And it's not on this page, so I got to go to the next page over here to get the proper database. There it is. And I can run a simple query on this table. So it'll pull up all the information. So if I go to the query editor, I can say, hey, look in any of these databases and then look in any of these tables in these databases. So I'm going to choose that database I just made. Actually, I remade this database, not because I did anything wrong the first time, but because I had an audio error on my recording equipment. and it'll automatically pull up the correct table. It's the only table in this database. And if you go to one of these automatic functions, preview data, it'll automatically fill this in for you. So it makes life easier. And these queries are very similar to Grafana queries. It's just going to take the first 100 rows, and then we can see what our format looks like. So it's going to run that query. We'll make sure that our format looks good, and we have all 5 sensor readings for humidity and temperature. And this looks good. It's going to start with the most recent to the earliest. And we're going to get 2 readings for each sensor because that's the way these Timestream databases work. And we're going to have 1 reading for temperature and 1 reading for humidity. So your database should look like that. Now, one thing I want to point out, and this is important when we do our queries in Grafana, since I used round numbers, Timestream automatically classified this as a big int. If I would have used like 100.1 or a decimal, it would have been a different format. I think it would have said like big decimal or big something else. So just so you know, that's going to make a difference because when we do our queries in Grafana, the format has to be exactly correct. And you're going to see that in a second. So let's move on to the second video where I'll show you how to do some graphing and connect this with a Timestream connector in Grafana to do some graphing of our Timestream databases. I'll show you a combined graph, which isn't going to be super helpful, and then I'll show you a more advanced query we can break it down into a separate temperature line and a humidity line. So let's do that next, and I'll see you in that next video. Okay, welcome to the second video here where we're going to do some visualizations for AWS Timestream and that newly created database. So what you need to do first is sign up for this Grafana web console. Now you don't need to download anything because just like Node-RED, this is the cloud-based version. So they have a locally installed version and a cloud-based version. We're just going to run the cloud-based version. The locally installed one might be more useful for you, but you can do this one first, and then once you know what's going on, you can deal with the locally installed version as they do in the AWS official videos. So once you have this dashboard on your screen here, we do have to do a couple things first before we can get into our newly created database on AWS. The first thing we need is a connector to Timestream from Grafana. So you're going to want to go over here to find and install plugins. Click that. And then the one we want, of course, is Amazon Timestream. So you'll click that and download it. Or if you just go over here to Grafana plugins, you can search for Timestream. And there it is, Amazon Timestream. And you can get that connector that way as well. But you're going to need this plugin to connect to your AWS Timestream instance, your database, and your table. Okay, so we have Grafana on the web. We're all signed up. We have our Amazon Timestream connector. Now, the next thing we need to do is our credentials. So let's go ahead and you can use your super user, your administrator access credentials if you want. I'm going to use the least privileged possible user. That's kind of the AWS standard. So if you go to your AWS management console where we just were in the last lecture, I can go here to IAM and I'm going to create a new user. And with the new user, I'm going to get the access key and the secret key, but I'm only going to get a user I configure to use Timestream. So it's extremely limited user, but that's the only user we need for this example. So I'm just going to go to users here and I'm going to create a new user, add user, and I'm going to call this Timestream user. Pretty good name. I'm sure I spelled that wrong. And let's go ahead and give them programmatic access and AWS Management Console access. You actually don't need to give it this one, but just to show you if you want to use this user later and recycle it, you can do this. And I'm not going to use this. So next permission, and I'm going to go ahead and attach an existing policy, a pre-made AWS policy directly to my user. So go ahead and click that. And of course, the one I'm looking for is like a Timestream all access. So I click in Timestream and let's go ahead and use this Amazon Timestream full access. I probably really only need read access, but I'm going to go ahead and get full access. I don't care about tags, so let's ignore that. Review it. Timestream user has Timestream full access. Yes, let's create this user. So I'm going to copy this one, my access ID. And I'm going to copy this one, my secret access key, which is the longer one. Now, you should never expose these, especially this one, but I'm just going to delete this user when I'm done. So put that right here. That is my first guy, and for some reason I didn't copy my access user ID, so I'm going to go ahead and copy that. and there it is. So there's my user ID and my secret access key. So these are good to go for me to put in Grafana when I use my connector. So let's do that right now. Let's go back to Grafana. I'm going to go ahead and connect. So that's down here under configuration, data sources. I have 2 instances installed. You're going to need 1. So click your default Amazon Timestream. Great. So this looks pretty good. So I'm going to put the user credentials right in here, but I don't want a credentials file. I'm going to make it easier, unlike the video. I'm going to use my direct access and secret key right here. So I'm just going to go in here, and with my newly created user, I'm going to put my access key and then of course my secret key. And don't share this with anybody else unless you plan on deleting that user, because you don't want to give them access to your account. And this is also known as AWS SIG v4 security. And this is actually what your AWS CLI is configured with to log into your AWS account. Okay, so this all looks good to me. So I want to say save and test, and hopefully my connection will be successful. And then if everything works, all my databases within this region will connect. So the one we just made was this one. So let's use that. It'll connect to that, and then it'll pull up the single table that I have. There it is right there. I'll save and test that. I don't need to check my measures. Of course, it has humidity and temperature there. I don't need to check those. So let's go over next, create a dashboard, and then we'll do an SQL query, and that'll allow us to graph some stuff. So you just hit this plus sign to create a dashboard. Add a new panel. And now from here, we have an empty dashboard. So I'm just going to make sure it's in Timestream here and my Timestream table. And you have a couple options. You can do a raw query or a sample query. Let's look at the sample queries. These are the ones that give you pre-made examples. So another one, we can say show table. Let's do that first 10 row one again. Again, this is almost the exact type of SQL we use over on AWS. So that worked. It just stuck them all together because of the time scale here is really compacted, and we can expand this out we want, and that'll look different. Let's try another query. Go over here and do another sample query, and then we're going to do a raw query so we can design our own table. But for our last sample query, first 10 rows, let's just say show measurements. That may only provide a table view. Yeah, because how the columns are formatted. But if we see this, then we'll just see our 2 measure names and our 2 data types. All right, whatever. You can play around with these queries, but let's get to the query that counts. It's going to give us a little bit better info. So I'm just going to go back here and create a new panel. So here's the command I'm going to use right here. I'm going to say whatever database this is pointing to and this data is pointing to, I want it all where the humidity is the measure name and the temperature is the measure name. And the reason that makes sense is if we go back here, our measure name is right here, so it'll reflect all these measure values. So coming back here, it's showing this over here. You don't actually have to push query. It'll actually re-query every like 10 seconds automatically. It's kind of on auto, so you can just kind of mess with that if you want to. And what I want to do is I want to get closer and fill this up. But you saw before it had that little squiggly line, so if you hit zoom to data, now it's going to fill the whole screen. Now you see there's 2 data points. I can go over here to visualization and increase the size of those points, change it to these different gauges. So you have all these visualizations, but maybe I want to mess with make it into bars. You can fill that up. I like to make these points stick out. So you have all kinds of configuration options over here. But you see it kind of put the humidity and the temperature. These happened at the exact same time, so it can kind of connect them. Okay, so let's do another query now and create another panel where we can separate the temperature and the humidity. I figured out how to do that, so I wanted to add that to the video, unsurprisingly. So you can come over here and create, and that'll allow us to create a new dashboard. I'm simply going to hit this add new panel. You can also use this, then add new panel. And make sure you're in your database and make sure you're in the correct data table within that database. And we're going to create one of these bar graphs, but we're going to do it directly from the query. If you want to add a lot of bells and whistles, you can come down here to these panels and do a bunch of modifications, as I've said before. So what we got to do now, instead of running one query, we're going to run 2 queries, one for temperature and one for humidity. We also can't combine both queries on the same query pane. So I have to have a query A and a query B, and then it'll combine it. So our first query is going to be this. And I'll go over what this query looks like. It's creating a time series here with time on the x-axis and temperature on the y-axis. So we can say measure name equals temperature explicitly and make sure this is the proper spelling and it matches. Or we can just say measure name equals $_measure and select temperature here. It just went ahead and queried it. But since I'm not selecting temperature and humidity in this third pane here, I'm explicitly calling it temperature here. Great, so that's temperature there, and you can see it's really focused in, and I'm going to show you how to correct that in a second. But let's go ahead and add our second query. So I'm simply going to come down here where it says A, this is query A, and I'm going to make another query called query B. It's going to automatically call this B. I'm just going to paste in the same thing, but I'm going to change my key legend here to humidity. I can call this whatever I want and it'll match up with humidity later, but let's call it humidity because that makes the most sense. And then here's where it counts. This is where the name has to match as a literal. And I'll provide you with this SQL query command so you don't have to retype this. And then I'm going to call this explicitly humidity here. So now it knows out of this database and this table as the second query to pull out humidity and graph it. So hit this query button again. It'll query both. Great, I have both right there. Now to zoom in, I can mess around with the time here of when the data was originally entered from our connector in Timestream. But I can simply hit Shift and it'll reformat it here, and I missed some of the edge, so I'm going to do it again, and it'll focus in further. Great, and you'll see that's my temperature. Actually, that's my humidity on top, and my temperature there on bottom. Anyway, so that's a little bit better graph than what I originally showed you, and I think this one's a little bit more fun you can play with, but it's a little more complicated, as I said. And one thing I want to mention, and I mentioned this in the previous video, since I used round numbers, my measure value on Timestream was listed as a big integer called big int. If I would have used decibels, this would be called double. So make sure whatever your measure value is, the data type for those numbers, that it matches up correctly with your query. Okay, hope that was helpful. Let's move on.